Dear students, today we are going to solve question number 4 of exercise 8.1. The question is show that the diagonals of a square are equal and bisect each other at right angles. Solution. Here, first of all, we will draw up a square. Square, as you know, is a quadrilateral in which all the four sides are equal and one of the angles or each angles at the corner is equal to 90 degree. Here A, B, C, D is a square. Here AB is equal to BC is equal to CD is equal to DA, as well as angle A is equal to angle B as equal to angle C is equal to angle D. Each is equal to 90 degree because we are given ABCD to be a square. We have to show that suppose we join the opposite angles A to C. This is one diagonal and BD is the another diagonal. Suppose these two diagonals intersect each other at the point O. The question contains three parts. We have to, first of all, we have to show that AC is equal to BD, that is, the diagonals are equal, and bisect each other at right angles. We have to also show that OA is equal to OC, that means O is the midpoint of AC, and OB is equal to OD. This is the second part, and the third part is we have to show that AC is perpendicular to BD. Here, given ABCD is a square in which AB is equal to BC is equal to CD is equal to AD. To prove, firstly, we have to show that the diagonals of a square are equal. That means AC is equal to BD, the second part, and bisect each other. That means OA is equal to OC and OB is equal to OD. The third part is we have to prove that AC is perpendicular to BD. Now, first of all, we will compare two triangles, triangle OAB and triangle OCD. Here, AB is parallel to DC and AC is the transversal. So it implies that this, suppose we name this angle BAO or angle BAC to be angle 1, this angle 1 will be equal to angle 2. Why? Because AB is parallel to DC, these are the opposite sides of a square, and AC is the transversal. It implies that the alternate interior angles are equal. That means angle 1 is equal to angle 2. Likewise, this angle 3 is equal to angle 4 because AD is parallel to BC and AC or BD is the transversal. So angle 1 is equal to angle 2 and angle 3 is equal to angle 4. In triangle OAB and triangle OCD, angle 1 is equal to angle 2 because alternate interior angles, as AB is parallel to DC and AC is the transversal. Again, AB is equal to CD. Why? Because these are the opposite sides of square. This AB is equal to CD, opposite sides of square. Again, angle 3 is equal to angle 4. Again, the alternate interior angles are equal because AD and BC are parallel to each other and BD is the transversal. So, alternate interior angles. Therefore, by angle congruency rule, therefore by angle side angle or ASA congruence rule, triangle OAB is congruent to triangle OCD. Since the two triangles are congruent, congruency implies they are having the same shape as well as the same size. When the two triangles are congruent to each other, it implies that the corresponding sides are equal as well as the corresponding angles are equal. What we require here this OA, which implies OA is equal to OC and OB is equal to OD. Why? Corresponding parts of congruent triangles. That is our second part. OA is equal to OC and OB is equal to OD. Again, we will consider the triangles wherein the diagonals will be shown to be equal. For that, we will consider the triangle ABD and triangle BCA. Triangle ABD and triangle BCA. We will show that these two triangles are congruent to each other. When the two triangles are congruent, then the corresponding sides are equal. From there, we can get AC is equal to BD. Again, in triangle ABD and triangle BCA. In triangle ABD and triangle BCA. This AD is equal to BC. AD is equal to BC because opposite sides of a square are equal. Opposite sides of square. Now, angle BAD is equal to 90 degree, and angle ABC, it is also equal to 90 degree because these are the angles of a square, and we know that the each corner angle of a square is equal to 90 degree. Angle BAD is equal to angle ABC, each is equal to 90 degree. AB is equal to BA, that is common to both the triangles. AB is equal to BA, that is common to both the triangles. Therefore, by SAS congruence rule, the two triangles ABD and triangle BCA are congruent. Triangle ABD is congruent to triangle BCA. When the two triangles are congruent, the corresponding sides are equal. It implies AC is equal to BD. AC is equal to BD. That is, the diagonals are equal. The last part, we have to show that AC is perpendicular to BD. For that, we will compare two triangles. Triangle OAB, again, we will show that the two triangles, triangle AOB and triangle AOD, that is, these two triangles are congruent to each other. When the two triangles are congruent, we will show that this angle is equal to this angle. And finally, BD is a line segment on which the ray OA stands, or the line segment OA stands. We know that when a ray stands on a line segment, the sum of the two adjacent angles so formed is equal to 180 degree. We will use that concept to show that AC is perpendicular to BD. Again, in a triangle OAB and triangle ODA or OAD. AB is equal to AD. AB is equal to AD. OA is equal to OA or AO. OA is equal to OA, that is common. Here AB is equal to AD because these are the sides of square. Sides of square are always equal. OA is equal to OA, that is common, and OB is equal to OD. OB is equal to OD as proved earlier. Hence are therefore by SSS, side congruous rule, triangle OAB is congruent to triangle OAD, which implies angle AOB is equal to angle AOD. Why? Corresponding parts of congruent triangles. Since OA stands on the line segment stands on, since the line segment OA stands on BD, the sum of the two adjacent angles so formed, that is this angle plus this angle, is equal to 180 degree. That means angle AOB plus angle AOD is equal to 180 degree. Here, since angle AOB is equal to angle AOD, that means in place of angle AOD we will write, which implies angle AOB plus angle, in place of AOD we will write angle AOB, because both the angles are equal. It is equal to 180 degree, which implies twice angle AOB is equal to 180 degree, which implies angle AOB is equal to 180 divided by 2, that is equal to 90 degree. That is, angle AOB has been shown to be equal to 90 degree. It implies angle AOD is also equal to 90 degree. That means OA is perpendicular to, which implies OA is perpendicular to BD. Therefore, AC is perpendicular to BD.